Okay, so here we got the results of a survey at Hilliard Darby High School. Students were asked if they had a job and if they worked under or over 20 hours a week. All right, so let's just dive right in answering question. What's the probability that a student does not have a job? Given that a student does not have a job, they are a freshman. So given that they do not have a job, what's the probability that given they have no job, they are a freshman? So the given's always huge. That's going to force you what to look at. So what's the probability that given a student does not have a job that they are a freshman? Well, there's 34 freshmen out of the 88 total. All right. And sometimes reducing fractions can be tedious. Let's just get a decimal really fast. All right. It's about 0.386. All right. What's the probability that a student is a freshman? All right. So this one, notice how there's no given. What is the probability that a student is a freshman? Well, there's 53 out of 216. All right. So let's do that. 53 divided by 216. It's about 0.245. All right. So actually, let me move this over a little bit because it says, are these events independent or dependent? All right. So we have this big long formula about so on and so forth. This formula that we were doing up here can be useful. This is more just thinking. But remember, probability that a student is a freshman given no job. All right. It's going to be the probability that there are a freshman and no job over the probability they had no job. All right. Remember, this is independent if it's equal to the same thing as the probability of being a freshman. All right, very notation heavy right now. But since these numbers don't equal each other, so since 0.386 does not equal 0.4245, are these events independent or dependent? They're dependent. All right, looking at these ratios, interpreting these numbers, freshmen are more likely to have no job. All right, what's the probability that a student works over 20 hours a week given that they are a senior? All right, so notice how now it's given that they're a senior, so we're very concerned about this row right here. All right, so what's the probability that a student works over 20 hours a week given that they are a senior? So it's going to be 10 out of 48. 10 divided by 48. It's about 0.208. What is the probability that a student works over 20 hours a week? Well, in this one right here, we're just looking at the 26. There's only 26 students that work over that time out of the 216 total, which is about 0.12. All right, so again, are they independent or dependent? They're dependent. Seniors are more likely to work 20 plus hours. All right, because those numbers are not equal. All right, basically we're looking for equality. All right, just a couple more problems right here and then we'll be done. Given that a student is a freshman, all right, so here's more about students and grade point averages. What is the problem? Okay, given that a student is a freshman, so we're very concerned about freshmen. What is the probability they had a 4.0 or better? So 120 out of 340, 0.352, or about 0.353, excuse me, after I round. What is the probability that a student had a 4.0 or better? So this is just any student. Notice how there's no given now, so it's going to be that number compared to that number. 444 over 1258. 444, 1258. And oh my gosh, it's 0.5. So this is independent. All right. Notice how the numbers equal the same thing now. It doesn't matter that it's given it's a freshman or anything like that. And we can even write frosh are no more / less likely to get a 4.0 or better. All right. Them being a freshman doesn't impact their ability to get a 4.0. It's independent. The numbers are the same. What is the probability that a student has between a 2.0 and 3.9 GPA given that they are a sophomore? All right, so this one says given that they are a sophomore. We read that right there. So given that they are a sophomore, we want to see how many are in that range right there. All right, so there is 216 out of 408. 216 divided by 408 is about 0.2529. What's the probability that a student had a 2.0 to 3.9 GPA? Well, there's 666 over the total. And it's about 0.529. All right, so again, equal. All right, so it's again independent. I spelled independent wrong. All right. Class grade. So being a sophomore doesn't impact grades. All right, you're no more or less likely to fall in that range just because you're a sophomore. All right, and then just two quick examples. So these last few things, we're looking at tables, interpreting data, so on and so forth. This last stuff right here is just going to be your classic plug and chug. All right, so probability of A given B, let me rewrite that, not the best. A given B, remember it's probably A and B happening over the probability that B is already happening. All right, and similarly, the probability of B given A looks incredibly similar, but the denominator will be different because now we have to say the probability of A was already happening. All right, so we're just computing those. All right, so just practicing our formula, getting good at how it works, so on and so forth. So in this first one, in number one, you're just going to plug in, well, the intersect is 0.25. The probability of B was 0.4. So again, we live in a time and age where we have a calculator. Plug it in there. It's about 0.625. That was the probability of A given B for number one. And then the probability of B given A, kind of running out of room, still 0.25, but this time it's going to be over 0.7 because that's the probability of A. And again, just plug and chug into my calculator, and we get about 0.36. I'm going to round a little bit. Okay. Same thing down here. Is now I can say the probability of A intersect B equals the intersection, or probability A given B is going to be the probability of the intersection over the probability of B. So it's going to be 0.3 over 0.8. Again, no incredible meaning on the problems we're doing right now. We're just getting used to the formula. That's the sole purpose of doing this. All right. And that's going to be the intersect over the probability of A already happening. So about 0.67. Okay, and that's it for